And we will open with this. Since math is made up of numbers, and all those numbers have a name, I like to discuss what their proper names are. Okay? Everybody that was in my grade 10 class has seen something like this sheet before because I did a page of it in grade 10 as well. Just going to quickly review it because as we go through grade 11 and as you go into grade 12, you're going to be dealing with more and more of the weird numbers, okay? And Mr. DeVries and university professors, they don't have cute little names for numbers. They call them what they are. So when they say an irrational number, you need to automatically know what an irrational number is, all right? So that's why I'm reviewing it. So we'll start with natural numbers because they're the easiest. Does anybody remember what the definition of a natural number is? Any part of it. Max.
Is it something like every positive number?
Yeah, that's exactly what it is.
It has to be like, what, it can be like half? Right?
Yeah, exactly. If I said to all of you, hey guys, let's pretend we're 3 and we're watching Sesame Street and let's start counting. We'd all start counting and we'd all go, what would be the first number we said? 1. We'd all start counting at 1. Is 1 really the first number? No, what's really the first number? Really? 0's the first number? There's no number smaller than 0? Negative's what? Negative infinity is really the smallest number, isn't it? Can we say what negative infinity is? So we can't start counting there, can we? So natural numbers is naturally, if I all said, let's count, we'd all start with 1, right? And we would not do that thing our parents do. 1, 2, 2.5, 2 3/4, right? We wouldn't do that. We would just keep counting. And how long could we count? Till infinity. Would we ever get there, Megan? No, we wouldn't. That's the whole point of infinity. Would some of you have to stop counting before others? Think about that question for a minute. If I said, let's just sit here and start counting, would some of us have to stop before others? Why, Burke? Some of us, you were right up to infinity, and then I just couldn't hear you because I'm old. Look. Well, of course, we would die. But even before we died, we would have to stop. Why? What comes after millions? What comes after millions? Billions. What comes after billions? What comes after trillions? Quadrillion. So Max is still going. What comes after quadrillion? Quintillion. Luke is still going. Is Luke going to get more gummy bears? What comes after quintillion? Pardon? Sextillion. Then what comes after sextillion? Septillion. What comes after septillion? Octillion. Then what? No. Burke dies at nontillion. Is anybody still alive? It's nonillion. There's no T. And then I don't even know what's after non. I can't remember what it is. But that's a lot of zeros. We wouldn't even get to it. I think I don't know. It might be decillion, but I'm not sure. I think 12 is dodecahillion. But I'm not 100% sure. Why am I not 100% sure? Because we don't count that high, ever. Nobody writes that many zeros. All right, so natural numbers are our counting numbers. And like Max says, he's a smart guy, that Max, it's 1 to infinity. They're positive, and there's no decimals, which automatically means there's no fractions. Because, of course, we all remember that decimals and fractions are the same thing. All right. So what then are the whole numbers? Is there more or less whole numbers? There's more. How many more? Just one more. What is that one magic number? 0. 0 plus the naturals. right? And then it's the same rules. So if I were to draw, you know, like those dolls from Russia that start little and get big? I don't know. I know they actually have a real name, but everybody just calls them Russian dolls, which is kind of racist. Not really racist, kind of countryist, but there's not really a name for that. Because I don't think they indeed came from Russia. I think they came from one of Russia's republics, like the Ukraine or something, but everyone calls them Russian dolls. Anyways, you know those dolls? I used to have one, but my dog ate one of the middle-sized ones. So now it doesn't work anymore. Now they rattle funny. Speaking of rattles, I saw a rattlesnake in California, and they ran over it with my van. I came around a corner. It was in the middle of the road, lying in the sun. It's like, oh, wow, there's a snake. And we drove up to it, and it was like a big-ass rattlesnake. My kid's like, oh, my God, a rattlesnake! And they go to get out of the car. Like, you idiots, just take a picture of it. Oh, yeah. They're holding their phones with a camera on it. They're like, I want to get out and see it. It's like, you'll let the dog out. The dog get bit by a rattlesnake. We're miles from everywhere. It's so embarrassing when your own kids do stupid stuff. Just curious, you've had your hand up for a while. Do you need to pee?
No, it's called Matrushka doll.
Pardon me? Oh, Matrushka? I like the sound of that. I'm going with it. I will no longer call them Russian dolls. I'm going to Google it at lunch just to make sure. Okay. But yeah, you know what I mean, those dolls. So the naturals would fit. That looks like a W, Myers. The naturals would fit. Come on, erase. Erase. I'll just wait a moment. Erase. 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 The naturals would fit into the whole numbers. Okay, now what are the integers? Yeah, integers go negative infinity up to the whole numbers, which then go up to the naturals. But then otherwise, it's the same rules. So here would be the integers. Now I want to remind you guys of something. This system here, I mean, technically naturals already goes to infinity, right? Which is going forever. All we've done is add the other end of this. They're technically the same size, right? It's just for illustrative purposes, okay? Now, the reason I stress the word integers here is because as you go on in math, you're going to see this word a lot. Integral. That means you are dealing with integers. So there will be no decimals or fractions when you see that word integral. Cool? And then there's our friends, the rational numbers, which is everything from up here. So we're going to go again with rationals. Rationals are everything above plus fractions and some decimals. Does everybody remember what the rules are for fractions and decimals? For fractions, what does it have to look like? Luke?
I was going to say, it can't go on forever.
Yeah, so that's the decimal. So I'll slide over here and we'll do decimals. It's supposed to be green. Piece of crap. Decimals. Luke says the decimal has to end, or what's the other thing it can do? Do you remember? Repeat. It has to end or repeat. So 3.75, it ends. It's rational. 3.729729 ... It's rational because 729 repeats. Everybody cool? All right. Now what about for fractions? It has to be some number over another number. And these have to both be integers. And y can never equal 0. So every single fraction you have, as long as it's integer over integer, it's a rational number. Everybody cool? Now, here's why I bring this up. You guys know this construction. You call it a fraction, yes? In math class, your teachers and professors, when they say a rational number, like a rational exponent, they mean that. Even though it's all these other things, they mean this. So the example I'm going to give you, and don't write this down, 6 to the 2/3, your teachers and professors and so on call that a rational exponent. They don't use the word fractional, even though that's the word we all use. Everybody with me? That's why I'm bringing it up. That's why I'm stressing the names today. Because as you go further, especially as you consider university, no fun names. They call it what it is. Everybody cool? Okay, and then you guys are smart kids. I've covered rationals. I've covered natural whole. Irrationals are everything else. But in math class, it's mostly square roots. I'm not going to write a square root. That was silly of me, but I'm not writing anything because my computer's frozen. Square root of this that doesn't work out. So any kind of root that doesn't work is irrational. Pi is irrational. Okay? Now, here's where it gets a little hazy. Square root of 2, rational or irrational? Irrational, because it's 1.414, goes on forever. Square root of 2.2. What do you think? Rational or irrational? Irrational. Okay? Now, square root of 2.25. That one is rational. Why? Because it's the square root of 225 over 100, right? Which is the square root of 225 over the square root of 100, which is 15 over 10, which is 1.5. And pretty soon, my frozen computer will write all that out. And don't worry, we're going to review that if that is not in your head anymore. Is everybody cool with numbers? Okay. In that case, turn the page over and just do section 1, A through G. Stop there. It should That's my favorite math joke. Do you get it? 3 people are smiling. 3 people aren't saying anything. A bunch of people are going, oh my God, you're so pathetic. I know I said it last year. Adina's laughing. Huh? On you. But some people weren't in my class last year. It's a funny joke still. Totally. Don't say it isn't. Come on, Max. You still like it. You can, yeah, come on. Don't be that way. Yeah. All right. So, what's the first one? Irrational. Because there are no three numbers that multiply to negative 14, are there? Great. What's this one? It is rational. What else is it? It's natural. But if it's natural, that automatically makes it whole, integer, and rational, right? Okay, what about this one? Somebody always gets this wrong. What is it? It's rational. Why? Because it ends. What about this one? It is rational. Does it get any smaller than rational? It is natural. Why? Because it equals positive 16. Nice. What about 9? Natural, because we'll get to it when we count. What about that? Is it irrational? Cole? Pardon? I can't hear you. Integer? Nope. It's not even irrational. It's actually nothing. It's what we call, I didn't even tell you what it was. It's not even a real number. It's an imaginary number. Because you can't have a square root of anything negative. Now, the reason I bring it up is because just when you think you're comfortable with math and all the real numbers, your math professor is going to introduce to you negative or imaginary numbers. And then you got to learn a whole nother set of math. But don't worry about that. I don't do that to you. That's not till later. Okay? Okay. And then what about that one? Why do you think it's rational, Burke? Because it repeats. Can you guarantee me that's rational?
If it was rational, or if it was repeating on another thing itself.
You could, if I wrote it this way with just the bar, then it's absolutely rational, isn't it, Luke? But when I write it this way, it appears rational, but who's to say there might not be a 7 somewhere way down here? Understand? What?
But doesn't like the dot dot mean that it's the same?
The dot 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 just means, technically means it continues. That's why I'm splitting hairs here, Sonia. Because, as Luke says, the bar means everything under the bar repeats. The dots just means it goes on. So it appears rational because it starts by repeating. So what would be the best way to answer that question? Appears rational. Picking up what I'm putting down? Everybody cool? All right, now that we've done that, here's your first little test. It's not really for marks, even though it says it's for marks. Notice I say you have to take a -1 if you miss or tick in the wrong box. So don't guess. Everybody ready? Go! Just to see if you were really paying attention. How long are you guys here today? When's class end? 11:23. Oh, crap, we're running out of time. I hate Thursdays. Because I like students. I mean, one day maybe I won't, and then I'll retire. Or I'll quit teaching, I won't retire. But as long as I like you people. I'm going to do the Jeopardy theme in my head once, right now, and then we're going to start. Bong, bong. Time. There are 23 ticks that you must have in this box to get to, if you did it perfectly. Where's the ticks in the first row? Don't be wusses. Where's the tick? It's in rational. Is it anywhere else? No. Nicely done. How many ticks need to go in the second row? All of them except irrational. 1, 2, 3, 4. What about the square root of 81? Same thing. Look at you guys, smart kids. What about negative 2? Integer and rational. What about negative 1.5? Rational only. What about 0.215? Rational only. What about pi? Irrational only. What about 0? Whole. Integer. Is it rational? Is it rational? Can you write 0 as a fraction? I have no pizzas, right? Do I have any pizza in my hand, Megan? You can have half of it. So it's 0 pizzas divided by 2. How much pizza are you getting? 0. So can you write 0 as a fraction? Can you put 0 on the bottom of a fraction? No. So you still have to make him rational. What about 0.15155? What makes it irrational? I see 1s and 5s all over the place.
Yeah, those
2 5s in a row. Can't fool you, Max. Root of 3? Root 3? Don't go to your calculator for root 3. It's irrational, you guys. What about negative 8.1? Rational only. Why isn't it an integer? It's negative. Because there's a decimal. Negative 153. Integer rational. 3.14. It's pi. Isn't it irrational? No, because it's what we use for pi. It ends. And what about 23 over 8? Irrational. Nice work. How many people got 23 to 23? Who got, what fooled somebody? The 0? Was it 0? Mess with your heads?
I didn't put anything.
You didn't put anything for root 3?
I didn't put
Ticking's a lot of work. All right. Write true or false. If it's false, tell me how to make it true. Mr. Keeley walked by. Lovely. Is A true or false? I heard both. Which is it? Why do you say it's true, Max? I'm not saying if you're right or wrong. Why is it true?
natural go to everything except for irrational numbers.
Yep, it is true. All integers are rational numbers. Is that true? Yes, sir. Or ma'am. All whole numbers are natural numbers. False. So how can we fix that? Right. 0 is not natural. So all whole numbers except 0. Excellent work. Is everybody cool with numbers? Awesome. How many of you remember exponents? How many of you thought exponents were real easy in grade 9 and then you got to grade 10? There's nothing new in grade 11, but I like to review exponents from the 10th grade. So, this is all grade 9 stuff, so you shouldn't need me at all. Powers represent repeated multiplication. I can't stress this enough. If you can't remember how to do exponents, then know what they are. What is 7 to the 3rd power really? 7 times 7 times 7, which is 343. What is x to the 3rd power really? X times x times x. Naughty. Everybody cool? Remember that. If you get in trouble, know this from the 9th grade. Then you're always going to be okay. All right? Here is what we are dealing with. 7 to the 3rd. What is the base? 7. How do you find the base in every power? Where does the base live? Describe to me how I, as a blind person, could find that base. Where would I go in the physical world? Where is it? Pardon? It's on the left side of the exponent. Okay. The base, and this is where you guys screw it up, is anything. Please underline, highlight, put a Mrs. Bad Crumble cloud around it. I don't care what you do. Make sure you recognize that it is anything to the left of an exponent. So in this case, it's 7. What is the base in this case? What's the base over here? What's the base? 4x. What's the base here? X. Does everybody understand the difference? The base here is 4x. The base here is x. Is everybody cool with that? That causes you guys problems a lot because you don't actually understand where the base lives. Is everybody good with that? Okay, what's the exponent? In this case, it is indeed 3. How do we find it? It's anything, and I'm going to highlight that again, anything written as a superscript, which is the little number above the line. Little and above. Now, why did I say anything? Because for you guys, it's always been what? A number or maybe a fraction, yes? It's always been an integer or a rational number, yes? Up to grade 11. Does the world of math go beyond high school in Abbotsford in grade 11? Yes. So now we start reminding you that it can be anything else. For example, I could have 3 to the power of 2x minus 1. What's the exponent? 2x minus 1. Does everybody understand that? You can have crazy stuff up in the exponents. For you guys, it's still, even this year, is going to be regular numbers. But I need you to be aware that it can get more than that. Cool? Okay. What's the power? Now, this always messes people up. What's the power? The power is the base and the exponent. So it's the 7 and the 3. And we read it as 7 to the 3rd. You all know that. There's special names. What are the only two special names? There's two exponents that get a special name and nobody else has it. What are they? Absolutely, it is squared and cubed. X to the 2, which is squared, or x to the 3, which is cubed. Nobody else gets a special name. You guys have 7 minutes left. Fill in that chart. We'll finish this up tomorrow.